Again for coming and learning all about Venom. So to start off, I just wanted to give a little bit of background about how this presentation came to be. For many years, I've been a cheerleader for all the unloved critters, the snakes, the spiders, the wasp, and the ground nesting bees, and everything else in between. And I found that talking about busting the myths about these animals and talking a little bit more about their venom actually helped these creatures with their public images. And so it also led me into quite the rabbit hole as I was going through and learning more about biochemistry of these venoms and the medical applications and all of that. So I thought, why the heck not? Let's do a whole presentation all on venom. So here we are. So to start off, I want to provide some background on what exactly venom is versus poison. In the simplest of terms, if you bite something and get sick, it's poisonous. If something bites you and you get sick, then it's venomous, right? Of course, it's a bit more nuanced than just that. Like all good biological concepts, they're gray areas and they're also disputed realms of science, which I'll cover a little bit of tonight. Venom typically is injected while poison is ingested, absorbed, or inhaled. And most, and maybe all venoms, I hate saying all because there are very few absolutes in the world of biology, but most venoms will not perform if they're ingested. They have to get into the bloodstream to be effective. And so they typically contain complex proteins and enzymes, while poisons are usually much simpler organic compounds and much smaller molecules. Venoms also are typically used for predation and defense, along with a few other tactics that I'm going to go over tonight, but poisons are almost exclusively used for defense. So to start off, I figured I'd throw out a couple trivia questions to see where you are. So true or false, some animals are venomous and poisonous. Do you think some animals are venomous and poisonous? Why don't you drop it down in the chat, true or false? Are there some critters that can be venomous and poisonous at the same time? All right, I'm seeing lots of truths, and that's true, especially given that, some of you said the blue-ringed octopus is your favorite venomous creature. So the blue-ringed octopus is one potent critter. Despite its tiny size, it is both venomous and poisonous. So don't eat it and don't touch it, even though it's really, really cool looking. The main component in their venom is a tetrodotoxin, which blocks sodium channels and causes motor paralysis and respiratory arrest within minutes of exposure. So despite its tiny, tiny size, it can really pack a punch. So leave them alone out in the wild. All right, what about what is the only major group of vertebrates that lack venomous species? The major group of vertebrates, those animals with the backbone that lacks venomous species in it. Got a couple votes for birds. I see mammals in there. More votes for birds. All right. Sorry, Ginny, it is not mammals. There are some venomous mammals, which I'm going to cover, but there are no known bird species that are venomous. But there's species like the hooded patooey, which can be poisonous. And so apparently in the 90s, scientists were preparing skins of this bird. And while they were doing this, they started experiencing numbness and burning in their hands while they were handling these dead specimens of the birds. And it was later reported in 1992 that this species contains a neurotoxin, homobacteriotoxin, which is essentially derived from its diet. So it's a toxin that's very similar to some of the toxins that you see with the poison dart frogs. So there are at least 6 species of poisonous birds out there. All right, last one, and this is kind of tricky. What is the deadliest group of venomous animals? So the deadliest group of venomous animals, and I'll preface this by not saying it's not their venom that typically kills people, but they are venomous. So this is a hard one, a little tricky. You'll get extra points if you get this one. Fish, reptiles, snakes, stingrays, spiders, Eddie's questioning things, jellyfish, amphibians, eels. All right, this is where I might make some people mad at me, but you might not be surprised that mosquitoes are the deadliest animals in the world because they're transmitting a lot of pathogens and toxins, or sorry, a lot of pathogens into their hosts. But you might be surprised that they're venomous. I certainly never thought of mosquitoes being a group of venomous organisms. But if you think about it, they're injecting chemical cocktails into your skin. So they're injecting chemicals to numb the area. They're injecting chemicals that help the blood to flow. And sometimes they're injecting chemicals to cause the allergens to react to all of that. So hematophagous critters like mosquitoes, leeches, and vampire bats in most circles are considered to be venomous. But this is one of those areas of science where people kind of go back and forth about whether or not they're truly venomous, because they're usually not using that venom as for predation or defense. But again, they all have chemical cocktails in their that they inject into their victims to be able to feed essentially. If you look at the deadliest venomous animal by the highest percentage of deaths following a bite, that would actually be the cone snail, which is pictured here on the side. So there's some estimates that 40 to 70% of cone snail bites result in a fatality. But the good news is that unlike mosquitoes, cone snails aren't commonly encountered, and it's even harder to get them to bite you. So we're pretty lucky in that front, even though they're quite deadly organisms. So around the world, there are at least 220,000 species that have been identified as venomous, but we're still learning all the time. We actually didn't know that things like platypuses were venomous until not too long ago. And so that number is very likely much higher. Most venomous animals fall in the invertebrate realm, with the Hymenoptera, the bees, wasps, and ants accounting for almost half of that number that we have there on the screen. There are things like scorpions and spiders and snails and cephalopods and all sorts of other types of invertebrates that also contain venom. And then, of course, we have our vertebrate taxa like fish. Lionfish are example of a venomous species. We have reptiles, amphibians, and mammals that are also venomous. Venom has evolved at least 88 times in different animal groups. And so it has evolved independently of one another, but sometimes we see that convergence of animals living in similar environments, dealing with similar predators, kind of evolving very similar venom cocktails, but not quite the same all the time. And you'll see that the toxins can vary by the group of animals and sometimes vary within even a species. When we talk about rattlesnakes, sometimes their venom varies geographically of where they're found. Interestingly enough, very few venomous animals use it as a communal defense, with the exception being our social hymenopteras, the social bees, wasps, and ants. Sometimes will collectively use their venom to help defend their nests. But most of the time, these animals are acting as individuals to use that venom. So, as mentioned earlier, venom is mostly used for predation and defense, but there are a few species that have some different types of uses for venom. For example, there are a couple species that use it as almost like a love potion. Some scorpions, for example, do an elaborate mating dance where the males and females will kind of lock their claws and go through dance-like motions. And sometimes he stings her a couple times to make her chill out a little bit. I mean, it's believed that him stinging her is causing a calming effect in this process. Similarly, the Indian tiger centipede that's pictured here is also known to bite females during the mating and also provide that kind of calming effect in that mating process. There are some ant species that have used their venom to actually kill fungal pathogens, while also using it. Some also use it to neutralize the venom of competing ant species. So kind of like using it almost as a medicine in both those examples. And then really fascinatingly, some animals also use it to create their own habitat. So primitive wood wasp species will actually use their venom to kill tree cells. They'll inject their venom into living tree tissue to kind of kill those cells to make it softer for them to build their nests in living trees. And then we've got things like the Amazonian lemon ants that actually will use their venom as an herbicide and selectively kill certain tree species in the areas that they're nesting in to allow their preferred tree species to grow, which is really wild to me. So animal venoms have been used in human medicine for thousands of years. More recently, several commercial drugs on the market can be dedicated to different venomous species, including things like enalapril and captopril, which are really important for heart and stroke victims and all of that. Those have been derived from snake venoms. More recently, we have some of these GLP-1 like chemicals that have been derived from Gila monster venom. And so some of the Ozempic craze can be thanks to our Gila monsters. So every day we're unlocking more secrets from the animal kingdom, but we've been using animal venom as medicine literally for millennia. It just hasn't always been written down and hasn't always been part of Western medicine. So let's start talking about different venomous animals. I figure I'd start with one of the least known groups of venomous animals, and those are our venomous mammals. There are around 446 species of venomous mammals across the world. A lot of them are small guys, but the exception is our platypus, which is one of the largest venomous mammals that we have. In our area, the only venomous mammal that we know about is the short-tailed shrew, pictured here on the screen with his pointy little nose and his tiny little eyes. They have a neurotoxin in their saliva that helps them take down significantly sized prey, but it's not something that if they were to bite you is going to cause you to have to go to the hospital or anything like that. Apparently, it is a pretty nasty bite. It does hurt quite a bit, so don't play around with the shrews if you find them in your backyard. The thing about the short-tailed shrews and a lot of the other shrew species locally is that they have this intense metabolism and they have to eat every 2 to 3 hours. Otherwise, they essentially will starve to death. So that venom really helps them to be able to paralyze that prey and consume it so they can keep up with their ravenous eating habits. The male platypus also possesses these spurs on their hind feet. You can see it pictured here at the bottom. They're pretty decently sized. I think they're a little over an inch. And what they do is they use them during the breeding season. They essentially like fight other platypi with those hind spurs and kick them and all of that. So that's to essentially, fight off potential suitors so they can get breeding privileges. But occasionally, some humans have gotten stabbed in the process trying to handle or capture platypuses. So the only venomous primate that we know about are the slow lorises. So there's several species of slow lorises. These are really, really cute guys. They're nocturnal, so they've got these giant eyes and all of that. And I remember in the early days of YouTube, these were all over YouTube because there were these cute videos of them wanting to be tickled because they were raising up their arms and people were tickling them. But there's kind of a more sinister side to that story. And the reason that they were raising up their arms was not really to be tickled, but they were trying to defend themselves. You see, slow lorises actually have their venom gland up in their elbow, but the only way that they can extract that venom is to use these modified teeth, these comb teeth, and be able to suck that venom from the gland into those cone teeth, and then they could use that to bite potential predators. So while they were doing this, it was mainly that they were scared and trying to use their defenses. Unfortunately, they're heavily found in the illegal wildlife trade even today. And in that process, those people that are trafficking them are pulling their comb teeth, making them unable to be able to use their venom to defend themselves. So, in addition to using the venom for defense, they also use their venom medicinally. So, they've been known to groom themselves using some of that venom from their comb teeth. And essentially, by doing grooming themselves and grooming their young, it's supposed to protect them against ectoparasites and everything. So, moving along to our reptiles, did you know that we can thank Gila monsters for the current GLP-1 proliferation on the market? So, Gila monsters are the only venomous lizards in the United States, at least natively. And unlike snakes, they deliver their venom through their teeth. They don't have fangs like snakes. The other thing is that unlike most other southwestern desert lizards, the Gila monster is kind of slow and kind of chunky. So it doesn't really use its venom to kill its prey. Usually its prey is also slow and defenseless, like baby mice and things like that. But it uses its venom to be able to defend itself against predators like coyotes, which it obviously can't outrun. So part of the chemical cocktail in its venom is this stuff called exendin 4. And exendin 4 is similar to that human hormone GLP-1, which increases insulin production in the pancreas. So the lack of naturally occurring GLP-1 in humans is one of the causes of type 2 diabetes. And it's taken many, many years for researchers to be able to unlock these secrets. But now, as you can see, with all of the GLP-1 analogs on the market and all of that, we've figured it out, all thanks to the Gila monsters. But now our Gila monsters really are in trouble. They're dealing a lot with habitat loss and invasive species, and also illegal wildlife trade and some diseases. So one of the articles that I have linked in the resource that I just dropped in the chat is about healing the Gila monsters and trying to save these really important and really fascinating critters. So snakes are some of the most feared venomous animals, and worldwide, they're just over 135,000 deaths per year due to venomous snake bites. In the United States, that number translates to about 5 to 12 people per year. And oftentimes, the people that die in the United States usually have some underlying secondary condition like heart issues that ultimately causes that comorbidity. So, what's important to note here is that many of these deaths that are happening with snake bites are happening in the poorest and most rural areas. And a lot of it is due to the lack of access to clean hospitals or just hospitals in general, and also these antivenoms and things like that. So, we have high survival rates here in the United States because on the grander scale, our snakes aren't as deadly in terms of their venom as some of these species that you will find in South America and India and places like that. But also, we have greater access to healthcare that allows people to get the treatment that they need. So, snake venom is very different across species. And as I alluded to earlier, sometimes even within a species, it can change. So, we see neurotoxins and snake venoms, cytotoxins, the cell killing essentially chemicals, and then hemotoxins, which attack the blood cells or the blood system. So it's important to note that we have been using snake venom and figuring out how to make anti-venom treatments since the days of ancient Egypt. And we probably have been doing it even longer than that, but the first written records come from ancient Egyptian times. Last thing that I'm going to mention on this screen before I move on is just pointing out that most venomous creatures, including snakes and or spiders and things like that, they have these specialized venom glands that holds the venom. And then they're connected to whatever the delivery device is. In this case, it is the snake's fangs. Interestingly enough, most snake fangs are not really hollow, but they're kind of like have a groove down the center, and they really use physics to as they bite into whatever they're attacking. It's the physics of kind of the surface, not surface tension, but adhesion, cohesion, and all of that that's pulling the venom down into the wound. So Maryland has two medically significant venomous species, but we actually have more venomous snake species here in the state, and I'll talk about that in a second. The first medically significant venomous species that you're most likely to encounter are copperheads because they're spread throughout the throughout the eastern United States, but also throughout the state of Maryland. So I think they're found in every county here in the state. Their venom is relatively weak in terms of other pit viper venoms. It doesn't mean that if you get bitten, you don't need to go to the hospital. You should, but it's just, it's one that you have greater chances of less nasty side effects with the copperhead venom. It is hemotoxic, so it primarily goes after your red blood cells, which causes swelling and localized pain in the area, and sometimes on occasion it can go systemic. And they're the main drug or the main active chemical is contortrostatin. Promise I tried pronouncing all these things before this webinar and I'm still butchering them. So that has been isolated from the venom, and it actually shows promise in breast cancer research. So essentially, it's something that attacks breast cancer cells, but not healthy cells. And we see this in other types of animal venoms, wasp venoms, and some of the spider venoms as well. They have this like propensity to attack unhealthy cells like cancer cells. And so if we can figure out how to make these in larger quantities and all of that, we might be able to unlock some of the secrets of curing some of the cancers that we have. Moving along, timber rattlesnakes were once found throughout Maryland. They were found, I think, in every county, but of course, we have persecuted them to the point where they're considered to be an uncommon species here in the state, and they're mostly found out in the tiny western portion of the state. And they're still persecuted today. So they'll have these communal nesting sites and all of that. And biologists try to keep those sites under wrap because people will literally go there and just kill the whole den, which is really, really unfortunate. So timber rattlesnake venom compared to copperhead venom is a bit more potent, and it varies geographically even within this species. So there are 4 known types of timber rattlesnake venom that we know about. The first is type A venom, which is neurotoxic, which causes muscle weakness and paralysis. There is type V venom, which is hemotoxic that causes severe bleeding and tissue damage. There's a mix of type A and type B, and the rarest type is type C, which has the least impact, but it still has a venomous impact to it. So, and they've got they're a map of kind of the geographic distribution of these different types of venoms in the timber rattlesnakes. So across the United States, most deaths are from the crotalid species, which includes the timber rattlesnake, the canebrake, the western diamondback, and all the like. But they're also some of the most persecuted species. So one thing to know is that locally, researchers with the Susquehannock Wildlife Society up in Hartford County recently conducted a behavioral experiment with copperheads, and they placed a boot apparatus. You can see it right here, a boot on a pole right on top. Well, they placed it near copperheads, but they also placed it on top of copperheads. And then they grabbed them with tongs that had gloves on it, kind of simulating people grabbing those copperheads. And so they did these different techniques of disturbing the copperheads, and they wanted to see how the copperheads would respond. And not surprisingly to people who are familiar with copperhead snakes, but the majority of the time, they really didn't do much reaction. They were just trying to get away, or they'd vibrate their tail, or act like you can't see me because I'm camouflaged among the leaves, which they are very, very well camouflaged. And so the reason for not reacting, the reason for this behavior and not biting when they have that potential and that venom is the same for many of our venomous species. Venom is very, very costly in terms of energy to be able to produce. And I showed you that diagram with the venom gland and all of that. You only get a little bit to kind of go around. It's not like you can instantaneously make venom if you're a venomous animal. And so you have to be really careful about how you're going to use their venom. And snakes are actually known to be able to meter their venom. So if they do bite, sometimes it can be a dry bite, which is a warning bite. Sometimes it can be a bite with a little bit of venom, or sometimes it can be a bite with a lot of venom. If you are bitten by a venomous snake, there is no way to tell if it's a dry bite, little bit of venom, or a lot of bit of venom. You should still go to the hospital and seek care. But just know that the most of the time, these copperheads, at least in the study, were not biting. There were only 2 out of 69 snakes that tried to strike in this whole study. And so they really rely on their camouflage to get them by and be able to survive. Moving along, I said that there are a few other venomous snake species here in Maryland, but they are not medically significant species. And that includes our hognose snake and garter snake. So hognose snakes, they have that cute little upturned nose and they feed on toads. So they have to have these special rear-facing fangs to be able to significantly hold on the toads, as well as a mild venom that is able to essentially paralyze those toads in that process of them trying to consume them. So there have been really, really small number of cases of people who have accidentally gotten bitten by hognose snakes. Most of the time, they're captive hognose snakes that got bit during feeding or something like that. But they do have a mild venom. It's not medically significant, but it isn't going to feel the greatest if it does happen. Garter snakes also were long thought to be non-venomous until recently, and that it was found that they actually secrete a neurotoxic venom from their dubinois gland, which is it's not technically a venom gland, but it is a gland that's secreting that chemical cocktail essentially. And so the neurotoxin works well against their prey. But again, if they were to use it, I've been bitten by a garter snake. It's not going to cause a reaction that is going to cause you to have to go to the hospital. Interestingly enough, garter snakes feed on toxic newts. So like our eastern newts that have that red F phase, and then out west, there are garter snakes that are eating the Pacific newts and things like that. And so particularly out west, there's like almost an arms race between the garter snakes and the newts, one trying to become more toxic than the other to be able to, essentially the garter snake to have the toxins to be able to paralyze the newts, and the newts having enough toxins or to be able to discourage the garter snakes from eating them. So we see this kind of like arms race happening evolutionarily. So the garter snakes that feed on those newts, they can actually retain some of those poisons in their liver for weeks. And that makes those snakes both poisonous and venomous. So they're one of those dual species there. So for over 100 years, antivenoms have been the cornerstone of snakebite treatment. As I mentioned earlier, we've been trying to make antivenoms for snakes at least since the days of ancient Egypt. But we do have kind of a process that works well most of the time now. And that process includes collecting venom from the different venomous snakes, and then inoculating an organism or immunizing them with that venom. Typically, we use large animals like horses and sheep, which actually have very robust immune systems. And obviously, horses have a lot more body mass than humans. And so in that process, it causes the animals that have that venom injected to their bodies start to make those antibodies to fight that venom or that foreign compound that's been injected into them. So then after that, once the animals have that immune system response and you know that the antibodies have been targeting the venom toxins, the blood is then going to be collected, and then it's going to be, the antibodies are going to be purified out of that blood and used to formulate antivenoms to be able to treat snakebite victims. High quality antivenoms can be life-saving, but as mentioned earlier, there's an access issue to antivenoms, particularly in rural and economically depressed areas. And then the other flip side is that because the antivenoms are being made from the venom themselves, not only is it very expensive and a difficult process to do this, but some people actually, some of the patients have severe allergic reactions to the antivenoms. And so researchers are trying to figure out another way to create antivenoms that don't start with the venom of the animal that's causing the reaction in the first place. So, but we're not quite there yet. So despite the importance of snakes in our ecosystems, there are these things called snake roundups, which still exist in areas of the Midwest and southern United States. And in these roundups, literally thousands of rattlesnakes are collected from the wild and put on display as they're skinned, they're milked for their venom, and eventually killed. At one point, one of the activities in these rattlesnake roundups were stomping contests that they literally would stomp on and try to kill as many as they could in a defined amount of time. That's not happening anymore, but as you can see here from this picture from a recent one, that it's still a very large unsanitary environment and not obviously one that the snakes are going to get out of alive. So some supporters of the events will mention the importance of collecting venom for anti-venom treatments during the milking sessions and all of that. But the lack of sanitary conditions and you see a mixture of species sometimes in these different things, essentially that what's collected is useless. So it's not something that can be used for medical research. Some states like Georgia have turned their events into educational ones. So instead of focusing on eradication of the animals, they collect a small number of animals. They use it to promote the importance of these animals in their landscapes and all of that, and focus more on that education piece than eradication. But we still have at least a dozen of these rattlesnake roundups that still happen in the United States. So kind of a bummer, but I just wanted to throw that out there. So as we get into summer, I feel it's important to cover our cnidarians, which include our corals, our anemones, jellyfish, and the like. They're our oldest extant venomous animals, but they have these ancient venom systems. But if you've been stung by one, you know that they can take down very large, very advanced organisms like us. So yeah, it's still very, very impressive that their ancient nematocysts work so well. So work of art when they were designed, right? So part of the arsenal of these cnidarians are these things called nematocysts. Here's a schematic from NOAA down here. And they're these like essentially little pressure loaded capsules that have these barbs that once they get triggered, there's a little cap and a perculum on them, they get triggered and then those barbs shoot out with a thread. And then they're kind of like little darts that get into the skin of things like us. And they pierce through the skin or an exoskeleton and then release the venom into the offending structure that's getting close to these jellyfish or trying to eat them. So once the prey, or sometimes they use them to also capture prey. So if it is a prey, once they're immobilized, the tentacles will move their mouth and they'll pull those nematocysts back in to be able to reel in the prey and eat them. So there are more than 2,000 jellyfish species around the world, and there are also jellyfish relatives that I think are important to know about. So the box jellyfish over in Australia is considered to be one of the deadliest jellyfish and one of the most venomous creatures in the world. They often travel in large groups and they cause multiple stings, which sometimes can paralyze swimmers or cause them to go into cardiac arrest. So keep that in mind if you ever travel to Australia. Those box jellies are nothing to play with. To the south of us, sometimes as far north as like South Carolina, but also down in Florida, there are these things called Portuguese man-of-wars, which actually are not jellyfish. They're a gelatinous species, but they're considered hydrozoans. And I didn't realize this, but they're actually a colonial organism. So there's this huge bladder, this called a floating pneumatophore here, and then all these little tentacles are actually individuals, organisms, smaller organisms called zooids that hang beneath that floating pneumatophore. And they essentially work together as a whole happy family, stinging things and eating things all along the way in the water. Apparently, these things, even if the tentacles fall off, and end up on the beach. If you find them on the beach, their nematocysts are still active and can still sting you, and it's not a pleasant sting. So some jellyfish don't sting. There's a whole group of jellyfish called the comb jellies, some of which we have around here. Like I know I live in the Severn, and there are these little sea walnuts, and they do not have a stinger. So or a nematocyst. So sometimes you've got some jellyfish that are not a problem. So you've probably heard about the urine theory for jellyfish stings. It's a running joke. I've been stung by a jellyfish, pee on me, help me, save me, and all of that. I'm here to tell you don't pee on somebody or your friends or anything because urine does not work. Neither does meat tenderizer, neither does ethanol, putting pressure bandages on it, or even things like baking soda. Those are all useless for jellyfish stings. The treatment is actually dependent on what jellyfish stung you. So it really depends on where you're at. For most of the jellyfish that you're going to encounter around here, I read that using a blunt object like a credit card to essentially scrape the skin, and that would help remove any nematocysts that might still be stuck in the skin, and then applying heat, like a heat pressure pack or hot water or something to the area, because that helps dissolve those nematocysts that might be stuck in the skin and reduce the amount of venom being delivered. If you are in an area where there are box jellies, though, you can use vinegar. So vinegar will dissolve those nematocysts, and then that heat pressure pack or hot water will also help. But this is important to know. Vinegar on jellyfish stings locally is actually going to make it worse. So this is where it's important to know what stinging jellies are in the area that you're going to be swimming in, and the remedies just in case you get stung, because they don't work unanimously across the board. So moving along to more of our invertebrates, getting into our insects. We often think of things like the bees, wasps, and ants as being venomous, but we have some assassins that are also venomous invertebrates in our wake. So you might be familiar with the assassin bugs. This is actually the nymph or the juvenile version of the wheel bug, which is our largest assassin bug. It's got that big cog on its back. So we have multiple species of assassin bugs, and they have at least 2 different types of venom. And one venom, and they've got different venom glands to release that venom. So they have this like pointy beak that they not only stab their prey with, but they inject a paralyzing venom first and then a liquefying venom second. So they stab their prey, inject the venom, and then literally suck out their liquefied insides. So kind of functional in that regard. They won't liquefy your insides, but they'll give you a nasty bite. So don't play with any assassin bugs. Usually the juveniles have some bright warning coloration to let you know not to mess around with them. Important to pay attention to. Similarly, in some areas with wetlands, there's this terrifying creature, the giant water bug, which is in a different family, but same overall group. And these creatures are also known as toe biters, so they can get really, really large. And almost 3/4 of their venom is actually similar to assassin bug venom. So kind of fascinating. Even though they're in different insect families, they still have some of the similarities in their venom. And this one can also deliver a very, very painful bite to humans, but neither of them are considered to be medically significant. So I am thankful to say I've not been bitten by either of these groups of species. So moving along to our bees, wasps, and ants, and the hornets. Again, this is the largest group of venomous animals. Like more than half or almost half of our venomous animals fall into the Hymenoptera order. And as you might imagine, the chemical components really, really vary a lot. So this just gives you an example of some of the chemicals that are found in the different venoms, and it shows you like between bees and wasps, hornets, and ants where you see these things. So one of the things, some of these are specific to different groups. For example, melittin is something that you're going to find in honeybee venom in particular, and that is known to cause cell death, but it's also being used medically for a lot of different things, including cancer treatments as well. Wasp and hornets also have some specialized things. They've got hornet kinines and wasp kinins or kinins, and they're neurotoxic peptides that essentially help produce paralysis. And so they're usually used for subduing prey, but sometimes the kinins also are used to stimulate pain receptors. Ants, on the other hand, they have this formic acid, and they're also stingless bees that have formic acid, but it's mostly in the ant group that you'll see that. And formic acid actually acts as a natural preservative and a cleaning agent, so it has some different functions there. There's this researcher who unfortunately passed away a couple years ago, but Dr. Justin Schmidt developed the Schmidt Insect Sting Pain Index, where he painfully took on getting stung by multiple stinging Hymenoptera and essentially quantifying the pain based on how intense it was and how long he reacted and all of that. And not only did he do this for science, but he wrote up the funniest descriptions ever as these stings. And so, like, some of them are like, like wine reviews, like light and fruity, a feeling like a small buzz on a winter day, or something like that. Or like a jolt of pain, like a hairdryer being dropped into the water, or your skin being sawed off. So if you want a good laugh, read more about the Schmidt Insect Pain Index. And he also has this book, The Sting of the Wild. Really, really amazing researcher, and very sad to lose him, and all of that. But as you can see from this graphic, out of the Hymenoptera that he got stung by, the bullet ant tops it all. And this is a species or a group of species that you can find down in Central and South America. And they're actually rites of passage in some cultures of wearing gloves with essentially bullet ants and being stung by multiple bullet ants. Does not sound fun. On this graphic here, I most recently have been stung multiple times by these Metrichus paper wasp, which keep building by my house and on my grill. And this bubble is really small compared to some of the other bubbles, and I know that was not a pleasant experience for me. So just keep that in mind in all of this. Locally, the velvet ants, which are actually a type of wasp, and the females lack wings and walk on the ground and are bright red and black for several of the species. They are the ones that pack the biggest punch in terms of their sting. And one of the more common red velvet ants in our area is actually called the cow killer because of how bad its sting is supposed to be. So it's important to know that solitary venom from solitary species versus social species is very, very different. And that's because they've got different roles and functions. So most of our bee and wasp species are actually solitary nesters. And essentially, they're single moms that have to do everything. And I always joke, she ain't got time to sting you because they have to build the nest, lay the eggs, provision the nest, and do all of this in a very short lifetime. And most of the time, she's trying to go find insect prey that she needs to paralyze to put in there or collect a ton of pollen to put in there. And she'll have to like have some venoms that help kind of kill off any parasitic hymenoptera, like parasitic bees and wasps that might be trying to get into her nest. So you see the paralysis, you see kind of chemicals that do paralysis and neurotoxic peptides and proteins in that solitary venom. But in social venom, you see things that are more designed towards defense. And you also see in some of these larger social hornet or social wasp species in particular, like the bald-faced hornets and the yellow jackets, you see these allergens and pain-inducing chemicals in that venom. And so for example, one of the things in our local social wasp, if you've ever been stung by a yellow jacket and then it seems like the whole hive is chasing you, it's true because when one of those social animals will sting you, they will also inject pheromones into your skin that are tagging you as the threat, which is telling the rest of the hive that this is the threat right here and you need to go after them. And so that is part of the social venom. And of course, there are things like acetylcholine and stuff like that that's stimulating your pain receptors and really trying to discourage you from getting into their nest with all of their tasty little wasp babies. So a lot of these animals also, or at least a lot of our bee species, nest in the ground. And so I often get calls, particularly in the spring and sometimes a little bit later in the summer, of people who are panicked about ground nesting wasps in these different areas. And so our solitary nesters typically aren't going to have bright warning coloration, and they're going to do the little prairie dog thing, popping in and out of their holes, and they're very shy. And you will see them congregate in areas. Each hole, it belongs to a single female, essentially, and that's where she's going to be raising her young. In contrast to our social ground nesters, like some of our yellow jacket species, they're going to have a single entrance where multiple individuals are going to be coming in and out, and they have that bright yellow and black warning coloration. They are letting you know not to mess with them. So something to keep in mind there. A few other fun facts. The only female bees and wasps can sting because their stinging device is an ovipositor. It's a modified egg laying device. But that doesn't stop the males from trying to use what they got. So this hilarious photo is actually from a male potter wasp that is using its structures, sharp spines on its genitals, essentially to discourage this tree frog from eating it. So they're known as pseudo stings, but they don't have any venom that's being delivered in the process. And then, of course, bee and wasp venom is used so much for all sorts of different things. I just found out, like bee venom, there's things like bee tox to help with acne and other stuff. I know that bee venom has been used for rheumatoid arthritis and other anti-inflammatory drugs. So lots of potential there. It's just really hard to collect. All right. Last but not least, got to talk about our spiders. Almost all species of spiders are venomous. They're the second largest group of venomous animals around. There are around 50,000 species of spiders that have been described, and only about 25 that are considered to be medically significant. So a very small number of spiders are medically significant in that if they were to bite you, it's going to cause problems that you'll need to see a doctor. And the other thing is that you'll see numbers of the amount of deaths, like 5 to 6 deaths per year from CDC and stuff like that. but there's almost little to no research that actually shows where those numbers come from. It's so it might be even less than that. And we also know that a lot of these spider bites are highly misdiagnosed, and there's some research articles on the link that I'm sharing. So with our medically significant species here in Maryland are the northern and the northern and the southern black widow spiders. And the difference between the two species, you got to flip her over on her side and look at her hourglass. So if it's in one piece, it's a southern. If it's in two pieces, it is a northern. And the females are the ones that are toxic. The males have venom, but it's not as much. Um, the venom for black widow spiders, essentially it attacks your nervous system and your muscles, and it's going to cause intense waves of pain and cramping. And for mild cases, it can just be treated with analgesics, but around a third of the bites are more severe and might require antivenom and or hospitalization. There's a really cool study that was done multiple years ago where these researchers took gelatin fingers and little forceps and they poked them and they pinched them. Poked them once, they poked them multiple times, they pinched them on the leg, and then they pinched them on the butt, the meaty part of the spider. And not surprisingly, most of the time, the black widows were doing just like the copperheads, like leave me alone, trying to get away, silk flicking, trying to act like they were dead, stuff like that. Or they were giving dry bites when they got pinched on the leg. It wasn't until the pressure really started being applied to their abdomen, and the more pressure that was applied to the abdomen, that's when you started to see the venom being added to the bites. And the more pressure meant more venom. So, essentially the spider was metering its venom based on the level of threat. And I always joke, the whole point of this experiment is to know not to grab a lady's butt, especially not a black widow spider's butt, because she's not going to appreciate that and she's going to let you know. So the brown recluse, last thing I'm going to talk about, it's not established in Maryland. The brown recluse is not established in Maryland. We do get some hitchhikers that show up here and there. We've had some smaller infestations of Mediterranean recluses here in the state, but we don't have any confirmed established populations of recluses. We're way outside of the range. Only about 10% of the bites cause the tissue necrosis, and this is probably one of the most misdiagnosed bite out there, because all sorts of different skin lesions like MRSA and things like that have been falsely called recluse bites. What happens with a recluse venom? So, black widow venom attacks the nervous system and all of that, and the recluse venom attacks the cells. And what it does is it actually attacks the fatty tissues, the phospholipid bilayer on top of the skin cells, and it changes those skin cells and incites your immune system response. So what happens with these 10% of these bites that cause that tissue necrosis, so you're actually going to see a lack of blood to the area where the bite has happened. It's going to be purplish or white in color, and you'll see the redder, almost bullseye shape on the outside. And that's because of the slow tissue death that's happening there in the center. Something that's big and swollen and pussy, that is not a recluse bite. And there's this great mnemonic, and I have the research linked on the link that I've been sharing in the chat, and it's not recluse. So if you have a bite that's multiple lesions, that's not a recluse. If it occurs outside of the range, think about whether it's a fungal infection, an insect bite, or something else like MRSA. Think about the timing of when this bite happens. If it has a red center, remember the venom's going to prevent red blood cells from getting into that area. It's going to be white or purple. So if it has a red center or, abscess and all of that, that's probably not a recluse. All of these different things help to determine whether or not it is a recluse bite. So it's a really helpful mnemonic to know. There is a black market for venom. We're using venom for drugs, beauty, food, and even animal doping. Last year or 2 years ago, there was all of this venom that was actually destined for the Kentucky Derby to dope up the horses to be able to have them perform. And so it's all coming from somewhere. And a lot of times this undermines our conservation efforts, essentially. And so we see venomous species being taken illegally from the wild, being disturbed and milked for their venoms and things like that. So things to consider. And one of the articles that I have linked is from Operation Viper, which is a multi-year effort from Florida Fish and Wildlife Conservation that looked at the venomous snake trade that was happening out of Florida. And they did a really great job, but it's happening all around. So another reason why it's important not to let people know about some of the locations of the timber rattlesnakes dens, because sometimes people will also illegally collect them. So looking to the future, it's really, really important. A lot of these species are misunderstood. There are a lot of myths about them. So education and helping to appreciate these creatures for their beauty and what they contribute to our lives and our ecosystems is really, really important. And now more than ever, it's also really important to support conservation and research. A lot of these species like Gila monsters and things like that, they're still around thanks to people who have been doing the work to help them. But we're seeing major cuts to research, medical research, to conservation research, and all sorts of things at the moment. So be that voice for the voiceless. And if you want to learn more, there's some great resources out there. Snakes for Kids gets into venom and stuff like that. It's good book for kids. I've been listening to Venomous by Christy Wilcox in the car, and it's just been, I love her style, her writing style, and all of that. But if you want a more formal writing, then check out books like the Venom book by Ronald Jenner and Emond. And with that, I will say thank you. I went a little long. I'll share my link again, and I will take any questions that you might have. So thank you. And I'm going to let you all unmute yourselves if you want to ask a question out loud, or you can type it in the chat. So thanks all.
Are there any questions?
Yeah, saddleback caterpillars. I didn't get into the caterpillars, Robin, but yes, saddleback caterpillars, pus caterpillars, flannel, well, I guess they're a type of flannel moths. There are a ton of stinging caterpillars out there, so.
So Kerry, this is Eddie.
Hey, Eddie.
How are you?
Good.
Good. So you're out hiking and you're at least, you're at least a half hour away from your car,
Mm-hmm.
and you stumble onto you startle a copperhead, or you're in Western Maryland and you hit a timber rattler.
Mm-hmm.
You get bitten. Should you stay as calm as possible and stay put, or should you hike out and try to get to the hospital?
Yeah, that's a great question. So they always suggest staying as calm as possible, because when your blood pressure rises, that's going to cause that venom to go throughout your body. But I could imagine even me, if I got bitten by a copperhead or a timber rattlesnake, I would be quite concerned. So from what I've read, the copperhead venom is relatively mild in terms of venomous snake venom. And so if it's not a vigorous hike out of there, I would say that you probably would be fine. But if you have service, my suggestion would be to call a medical professional and find out what they suggest first. The timber rattlesnakes, those, if you're going to be in Western Maryland, it's probably going to be a little bit of a hike to get up into that place. And the more pressure that you put on that area where you're bitten, and the more that your blood's flowing, the more that venom's going to get into your body. So those are things to think about. But
would you even suggest a tourniquet, or not bother?
No, they do not suggest tourniquets at all for snake bites. So
Okay, thank you.
yeah, and there are also these little tools that people will sell. They're like little snake bite tools and all of that. And those aren't suggested either. So really, if you can keep that injured area below the heart and reduce the amount of work that you're going to do blood pressure wise and all of that, that's going to be the best thing to do. So
Great, thank you.
you're welcome.
Carrie, when
Hey,
I was
Jane.
volunteering down at the reptile house, Bela, who was one of the keepers, did a presentation on why you shouldn't do all those things that they used to tell you to do for a snake bite. Cut the X, suck the
Yeah.
venom out, do a tourniquet. He showed us pictures of the aftermath, and it was nasty.
Yeah.
So you're not supposed to do any of that stuff anymore.
I know. I remember being told when I was younger to suck the venom out, and I was like, "What?"
Actually,
Yeah,
Don't do that either.
actually, I just finished a wilderness first aid class, and if you have serious arterial or venal bleed, tourniquets are the thing to use.
Oh,
You have to learn how to put one on yourself, but
yeah.
you do use them, and the science has gotten to the point where it doesn't damage tissue the way we used to think it did. It's all an outgrowth of the wars in the Middle East.
Thank you. See a question. Dave Bender asked in the chat, are all recluse species invasive? I know the brown recluse came from Russia in a shipment from Russian literature. So there are several recluse species that are native to the southern United States. The brown recluse is the most notorious. There are a few other species that have much smaller ranges and all of that. I suppose in our area, like I would consider them to be non-native because they're not really, I mean, they're problematic if they bite somebody, but they're not something that's rapidly spreading and established here in the state. They're more of what we would call a waif, where it just kind of shows up here and there. There are the Mediterranean recluses. Some of the Mediterranean recluses are, we see those in areas like on a military base and things like that, where people are moving a lot of stuff around. And as their name suggests, recluses are reclusive. So, they're hiding in things, and so it makes it easy for them to stow away in boxes and all of that. I'll try to pull up the map of the different recluse species, and I'll drop that in the chat. Okay. And Melissa is just commenting that tourniquets are for bleeding, but not for snake bites. So thank you for that clarification. All right. Well, if there are no further questions, I hope you all have a fantastic evening. And thanks for joining in. And feel free to reach out if you have any questions.
Okay, Carrie, thank you so much for this great session. The information about the many uses of venom, such as medical advances, the cost of producing venom, and what might trigger an attack, and what to do if bitten are really useful and interesting. And then before we leave, I have a couple of upcoming events that I'd like to highlight for you. As I mentioned, tonight's webinar is part of an ongoing quarterly series. On September 3rd, Paula Becker will be joining us to talk about rare, threatened, and endangered species of Maryland. Paula is the outreach ecologist for the Wildlife and Heritage section of the Maryland Department of Natural Resources. I also have a save the date notice for the Frederick County Nature Summit on October 1st at Catoctin Creek Nature Center. Please contact Kelly Crittenden for details at kcrittenden@frederickcountymaryland.gov, and that is in the chat. And a recording of this webinar will be posted to the Nature Council website within a couple weeks, so feel free to take a look at it. So thank you, everyone. Have a good night, and we hope to see you soon.
Thanks, Patty. Thank
Thank
you all for
you.
joining.